Hello students, welcome to a video for 2-3, which is electron configuration. If you're watching this video and you weren't in class, please make sure that you get the bell ringer off the announcements on Canvas. Alright, let's go ahead and get started. We are going to talk about electron configuration today. One thing you definitely need is you need your periodic table handy. So if you don't have that handy, go ahead and hit pause. Come right back to us. Okay, so let's start with a definition of electron configuration. Electron configuration, we've been talking about the parts of the atom. Our electron configuration is like an address of the electrons. This gives us a very specific direction about what it looks like in the atom, because each atom has its own little set of electrons. So let's go ahead and talk about the Aufbau principle, which helps us get there. The Aufbau principle is also known as the building up principle. And so what that means is we start in the inner shell, 1s, we start at the 1s shell, we'll talk about that in just a little bit, and we'll build up, or so we'll move outward and move outward to 2s and 3s and 3p and so on. All right. Then we have the Polyexclusion Principle. The Polyexclusion Principle is where no two electrons, got a little ahead of myself there, no two electrons can have the same electron configuration. So each address is unique, if you will. Okay. Moving on to sublevels. So within each energy level, so we have the first energy level and all the way through 7 energy levels, we have what are called sublevels, and these are obviously parts of the energy level. All right. And they break down into multiple things. And so they break down into s orbitals. The s orbital is present in all shells, or all levels, right? And it can only hold 2 electrons. All right? It can only hold 2 electrons. The p orbital, and this has, I should say, the s can hold 2 electrons and it has 1 orbital. So within the sublevel, there's 1 orbital. The p can hold up to 6 electrons and it has 3 orbitals, because each orbital can hold 2 electrons. All right. So in the d, we can hold up to 10 electrons. So how many orbitals do you suppose they have? That's right, 5 orbitals. We'll extend this out to that guy too. And then the F can hold up to 14 electrons. We're not going to use these a ton because they start to do some weird stuff down towards the bottom. And we're trying to keep it fairly simple. But there are 7 orbitals available in the Fs. So each of these orbitals can hold 2 electrons. Now, what we have going here is how to write an electron configuration. This is going to be a little different than you'd probably see in a college textbook or even just in a textbook, but I found it easier this way to see it like this. So this kind of random set of numbers and letters actually tells us exactly how to type out or how to organize our electrons. So let's go ahead and see if we can't use that to do that. And we're going to use the Aufbau principle, which says build up, start at the beginning. So we're always going to start right at the beginning, right here, always at the 1s, and build up. So here we go. Let's look at hydrogen. So the first thing for hydrogen, when we have one of these, the first thing we need to do is we need to find how many electrons hydrogen has. So we look at hydrogen. Hydrogen has an atomic number of 1. So it has 1 electron to place. So this is going to be fairly easy. We're always going to start right here. So we're going to say 1s1. This 1 up here signifies how many electrons we have in that sublevel. All right. So since s can hold up to 2, we only needed to place 1. So we were okay there. Let's try a little tougher one and let's go to carbon, all right? Kind of work our way on the challenging ones. We've got carbon here. Carbon is 6 electrons, so it has 6 electrons. Again, we're going to start right at the beginning. Let's change colors here. So we're going to start at 1s. So we go 1s, and we know that s can hold 2 electrons. So let's go ahead and put 2 in there. So we've placed 2 of our 6, so we need to keep going. So next comes our 2s. So we say 2s. Again, it can hold 2. So we've now placed 4 of our 6 electrons, so we've got to keep rolling. And we're going to go to 2p. Now we know p can hold 6 electrons, but we don't need it to. We just need it to hold 2. So we're just going to say 2p2. This is the electron configuration, 1s2, 2s2, 2p2 for carbon. All right, let's try a little more challenging one. We have chlorine now. Chlorine is abbreviated Cl. We'll change our color here. Let's go green. All right, so chlorine is Cl, and it has 17 electrons. Hopefully you found that okay. So again, starting back at the beginning, we always start at 1s. So we say 1s2. All right, we've placed 2 of our 17, so we keep rolling. 2s2. All right, there we go. 2p, this time we can fill all of our p up. It can hold 6. So we're going to say 2p6. We've now placed 10 of our 17, which means we've got to keep going. So we're going to say 3s2. We've now placed 12. If we add up our exponents, 2 plus 2 plus 6 plus 2 is 12. All right, now on to our next thing, 3p. 3p. P can hold up to 6, but we only need it to hold, that's right, 5. So we're going to say 3p5. This entire thing is called our electron configuration. Okay? Let's try one more that's a lot more challenging, and let's just go ahead and jump up to 10, the element 10, all right? And it is abbreviated SN, so if you're finding it on your periodic table, it's number 50. All right, we have 50 electrons, okay? So we're going to have a little work to do. We're going to have to follow that little sheet quite aggressively, all right? So we're going to start at 1s, as always, so we're going to say 1s2, keep rolling. 2s2, all right, 2p6, we've placed 10, so we definitely have to keep going, we have 40 more, all right, so 3s2, 3p6, all right, 4s2, all right, now we're at 20, 3d10, we're at 30, all right, 4p6, that takes us through 36, so we got to keep rolling. 5s2, all right, we're at 38. We're going to go 4d10. All right, so we're now at 48, so we're getting real close. And then we say 5p2, because we only needed 2 to get to there. And that's how we do electron configuration. Awesome. See you next time.